It should record in a minute. Yep, you are recording. And what I'm going to do is also I will share my screen. Let's hope that this works as well. So, and we are going over to this one here. Can you all see the screen that I have up here? Is that visible? Ah, brilliant. So technology works. Now that's very pleasing. Fantastic. At least that works. I don't know whether there is a Moodle link for attendance. The first years, they have a student, and I absolutely love him to bits. He is the first one who posts the link to the attendance recording on Moodle. I haven't checked whether there is one here for this session. If there is, please record your attendance, because that is sort of, that helps us to keep track of engagement. And Emily, thank you very much. That's absolutely lovely. Thank you very much for the link. Usually we give a round of applause to the person who posts it first in the first year. That's quite funny. So, but please keep your microphones muted, otherwise I go completely nuts. So, right. We've got another 2 minutes. So I want to wait a little bit. I hope I'm not going to take up all your time today with this discussion for this practical, which I have sort of inherited, and I'm not entirely sure how this actually happened. I am very, very well, thank you, Alex. All good. We've been up more or less since 3 o'clock, so all good. Life is good, and I hope you are all right as well. Well, I'm so sorry, Camilla. I hope it's not too dreadful. 3 o'clock. Well, first I needed the toilet, then the dogs needed the toilet, then I had to get up anyway, and then I had to walk the dogs, and there was no more time to really go back to bed. So I do need sleep, trust me. Oh, good. Oh, I'm glad. As long as it's throwbacks and not throw ups, that's the most important thing. Okay, let's get started before I talk even more rubbish. Oh, thank you. That's really kind of you to say that. It really makes my day. Anyway, let's get started. So, very warm welcome to this session. And I thought I probably should start telling you what we actually wanted to do, but for obvious reasons, we can't do it. So ideally, what we wanted to do with this mini project in the second year is we wanted you to express a protein, express an enzyme, and purify that enzyme, and then characterize this enzyme by doing some enzyme reactions. That was the plan, and in previous years this worked fairly well, but this year is not a usual year, so we had to frantically change everything. And we decided, well, ideally what we want is we want people to do some enzyme analysis, because that is what they are probably going to do quite a lot in their final year. So we wanted to give you exposure to that, and therefore we decided to put this part, the enzyme analysis, first. So it's a bit like upside down, the whole thing. And then we thought, okay, what we can do is the first part where you express the enzyme and purify the enzyme, we can then do that in the second part of the first term. And then you can do the write-up very comfortably over Christmas, and everything is hanky-dory and tickety-boo. But again, it didn't work out like that. So I had planned, no, I wasn't in the frame for doing this practical at all. But then people said, oh, we need to shift everything, and we have to put everything online because of the pandemic. Can you do something? So I thought, okay, I can try and set up something for online, although I didn't know exactly what I was supposed to do. So I spent about 50, 60 hours over my Christmas holidays to come up with an idea for how we can do a practical to actually measure the samples that you have produced already from this enzyme purification. And oh, can I please ask to mute? This would be really great. Thank you very much. That's great. So I'm not entirely sure if I'm totally getting the things that you have done. So what I thought is I ask you first what you have done in the practical, because then we can build up on that. And then we can do this skills practical, which is scheduled for week 14. But since it's online, you can basically start whenever you want after this session and get it done and out of the way. You don't have to wait until next week. So I assume that most of you who have done the face-to-face practical, you have used some cell extracts and purified these induced cell extracts on a nickel column, on an affinity column. Is this assumption correct? Have you done that? Ha! Brilliant. So, what? Excellent. Thank you. That is incredibly helpful. So you have collected. So, no, let's go back. You have basically a sample with cell extract. So, cell extract. And this sample was induced with an inducer. And you then waited for some time for the induction to work. You collected the cells, you lysed the cells. Is that right? Lysis. And then the next step was you put that onto a nickel column. Oh, my drawing skills are totally pants, but I hope you know what I mean. And you collected a number of fractions from that. Am I correct with that? Does that sort of represent what you have done? Excellent. Brilliant. Thank you so much. That's incredibly helpful. Now, what did people do who did not do the face-to-face practical? What did, because I guess not everybody did the face-to-face. What did people do? You just simply got, okay, so you just read the manual. Excellent. So in a way, this is what I thought uh, for that I get this as an answer, and that is in a way that is quite helpful because at the end this will bring us all together and makes life much easier for me. So for those who did the face-to-face, obviously we can't measure now the samples that you collected, but what I have done is I have prepared some virtual samples. Virtual samples for you. And I think it's about 27 or something like that. So it's quite a lot. And the instructions, what these samples are in the manual that my colleague Rosalind Masterton has provided you with. So you've got basically 27 samples or so, which are relating to these fractions here that you get from the column. And we also have some cell extracts. And I think the way I named it, this would be a cell extract CE, that stands for cell extract, induced. And I can't remember, I think I called it P for protein. But I think Rosalind also calls it CEIB for Bradford. I don't know why she changed that, but so if you see CEIP and CEIB, that means exactly the same. We have also prepared another sample for you, which is a cell extract which did not get the inducer, that is not induced. That is what we prepared for you. And this is called, if I remember correctly, CENP. Obviously, we don't want to purify anything from this one, but so there's no purification because there should not be any enzyme that we are interested in expressed in it. So no purification. We haven't done that. We've just done this sample extra for you. Oh, okay, yes, good idea. If you can't hear me, then it's pretty pointless me saying anything at that point because you can't hear me. But the chat is a good suggestion with the, okay, good. Okay, Thomas, excellent. Welcome back. So what our job is now is to find the protein concentration, of all the samples, that have been collected. so that have been collected. And naturally, what you would do is you would use a protein assay. You did one last year in your first year where you did the BioRat assay. BioRat. It's a T, isn't it? BioRat. A BioRat assay in one of the BI308 practicals. In this mini project, we are using a very similar assay, which is called the Bradford assay, which is a little bit more robust. It is not terribly sensitive to any inhibiting factors like salt or something like that. So for this one, we use the Bradford assay, but the principle is exactly the same. So we measure the protein concentration by just simply adding some compounds to some fractions from our samples. And then in a spectrophotometer, we measure the change in absorbance. Does that make sense so far? Are you happy with that? Excellent. Good. And like you did last year with the BioRat assay, what we are trying to do is to measure the protein concentration of these samples. And to do so, what we want to do is we want to use a standard curve. So like you have done last year, we use known protein concentrations. So known protein concentrations. And we usually use bovine serum albumin because that's very cheap. And we would plot here milligram of the protein. So here we have the different amounts. These are the known concentrations. And we are constructing with that, with these known concentrations, we are constructing what is called a standard curve. And you have done that in the BI308 practical, so that should not be anything new. And we measure these, the absorbance of these known protein concentrations. In a spectrophotometer, we just simply measure the absorbance of these samples. And what we should get is sort of a more or less straight line. So this might be our standard curve. Something like that. And as I said, this is the standard curve. Here we have the known concentration, let's say 10. Let's do it like that. Let's do it properly. 10, 20, 30, 40. And let's do that microgram to be realistic. So you have the standard curve. So when you now use your samples, so let's say we use one sample, let's call that, let's say we use CEIP. That's an induced cell extract sample. We measure that in the spectrophotometer, treat it exactly like we've done that here with the known concentration. And let's say we get a measurement for CEIP of an absorbance of this one here. So that would be CEIP sample. We then can use the standard curve to determine very easily what the corresponding protein concentration is. That's the point of the standard curve. Make sense? Are you happy with that? Okay. Now, of course, we can't really do that online, can we? Well, as I said, I spent quite some time in trying to come up with a solution for that. And I have set up a website for you. So here is the website. The link is, I posted that in the group chat, but it's also here on the chat right at the beginning. And I will put that also into the Moodle section for this. So here's the link to the website for this Bradford assay. And here's a little bit of introduction. Here is the experimental procedure. So how this actually works. And I urge you to have a look at that. And here is sort of an online version for this. So what you need to do is you first need to produce your protein standard curve. So you go to the online version, protein standards. And what you find here is an online spectrophotometer, right? And what we do is we measure the standards, we measure the protein, the known protein. Over here, we measure the known protein in duplicates, just to be on the safe side. So how do we do that? So here, this would be standards 1. You just simply select one volume of the known protein of the BSA. Let's say we select 10 microliter and run the spectrophotometer, and we get a reading. And we can do the duplicate for that. Again, that's the standard 2, 10 microliter, and we get a reading. Oh, okay. It's slightly different. So this means what we need to do in this case is we obviously would go for the mean of the two readings, and we can construct our standard curve. So we do that for all the volumes of the known of the BSA protein. And what I want you to do is really write down these readings in your lab book if you've got it. So that gives you the data for your standard curve. Okay, makes sense? Obviously, these are the means of the two standard points that are indicated here. So your standard curve is constructed with this virtual spectrophotometer, and you do the means. Okay, so this is the protein standards, and oops, and now we measure the samples. And I have a list of all the samples that you are going to measure. So for example, we have the cell extracts. And here you see we have the non-induced samples. These are the CEN, that's the non-induced samples. And we have the induced induced samples, CEI, and we measure them in triplicates because we can do a little bit of statistics with it. So again, like before, you can just click on that. So that is the first one. The non-induced sample would give us an absorbance of 0.343. And with our standard curve, we can easily figure out I come back to your question, Richard, in a minute. We can easily figure out. So this sample here would correspond to this protein concentration. What do I mean by induced samples? Well, as I said before, you use the cells, you added an inducer, and this inducer actually convinced the cells to produce the protein of interest, in this case, probably SAM or COP or whatever your protein was that you used. So these cells that were induced produce the protein. Cells that did not get the inducer did not produce the enzyme that you were interested in and that you are going to purify. Does that answer the question? I know that you have only worked with the induced cell extract. But as I said, we've prepared also a non-induced cell extract for you. So here are all the different samples, and you are required to measure all these samples. So here you have the eluted samples from the nickel column where you believe that your protein is located in it. So here SB1 and SB2, this is one of these eluted fractions, and we measure that in duplicates. So let's see what this one gives us, the SB1 sample. It gives us a fairly low absorbance. So that means there is not a lot of protein in it. We measure it in duplicates. Okay, good. So we would use the mean of this. Let's take the second fraction of the purified one. Let's see if protein is, oh yeah, oh cool. Look, there's lots of protein in there. I can already tell because it shows a strong absorbance, and I can go then into my standard curve and can say, oh wow, SB2 sample had a very high absorbance. So that would be quite a lot of protein here. Okay, so what I want you to do is really measure all these samples through and then determine the corresponding protein concentration. But you see, life is always a little bit tricky because we might have samples where we need to do a little bit of dilution. The dilution might be necessary because the absorbance would be too high and we can't measure it. So I've produced some tables for you. Here, that would be the table for the standards and what you would pipette together. And you can probably, I don't think you can download these tables, but you can use these tables for your calculation and your write-up. And here are also here are the samples that I want you to measure. And it basically tells you what the volume is that you use for these different samples. So in order to measure. So you can use this table again. So for the non-induced sample here, the top row CNP1, you would use 20 microliter to measure, and this sample was 1 in 10 diluted. You measure the absorbance for it, and you calculate the mean of the absorbances for these non-induced samples and determine the protein concentration accordingly. No, it would not make a huge difference. It doesn't matter when you average it at that point, so it's not a big problem. Either way is fine. Now, I know that people sometimes struggle with these things. And therefore, what I have done for you is I have produced a tutorial with example calculations. Your numbers will probably be different, but not too different. And this tutorial on the website will take you through each step of the calculations. Right? So I hope that it is as clear as possible. So what I want you to do is, for each sample, then I want you to calculate where you've got the absorbance. For each sample, I want you to calculate the amount of protein that you've got in there. Right? And that tutorial should guide you through it. So that's the first part. Determine the protein concentration of the cell extracts and samples from the affinity chromatography column. So that's part A. Part C is also fairly straightforward. Generate an elution profile of the samples, because once you've got your all the samples with the protein concentration, what you can do is you can plot the protein concentration here versus the sample number or sample label or something like that. And you probably get something, a profile like that. That basically tells you that in this case, in sample SB1 and SB2, there is lots of protein. And you know that sample SB1 and SB2 is the fraction from your from the column when you try to elute the purified protein. So that indicates that you've got quite a lot of purified protein available. You see sample FT1 and FT2. These are samples that represent the flow through from the nickel column. So that's all the protein that hasn't bound. And of course, these are the proteins that are of no interest, and there's quite a lot of there. So what I want you to do is generate this elution profile for your samples, for the basically virtual samples that you have produced, that you have collected, and that you have now measured in this virtual spectrophotometer. Can you do that? And again, the tutorial walks you through how you do that. Are you happy with that? Okay. Excellent. By the way, if there are any problems or questions, please do let me know. I don't want people to, go into agony and overdrive and feel lost or something like that. I really want you to get something out of it, because that is a very, very important skill that you really feel comfortable with that. So that is A and C. And I want you to also determine the 95% confidence interval for the cell extracts. Now that is a little bit of a twist to it. So let's go back to our beautiful standard curve. And I told you, what I want you to do is actually no, you don't. No, you don't know what you're saying. It would have been carnage. What I told you is I want you to measure the cell extracts in triplicants. So you have CE1P1, CE1P2, CEI, I should say, because it's induced. So we measure that in triplicates. And there is a very good chance that they are not all the same, right? Although they come from the same sample, there might be slight differences. So what we do is we measure CEI P1, CEI P2, CEI P3. These are the three induced samples, and we measure the average protein concentration. So that's the mean of the three samples of protein, of absorbances, I should say. Sorry. And let's say we get, oh, I changed the color. Let's say we get this one here as the mean. This is our mean of the absorbances. And now what we want to do is we want to find out what is the corresponding protein concentration. And you would say, well, this is really easy, isn't it? Because all we need to do is we need to go over, like we've done that with our standard, with the other samples, and read off here. And that would be our corresponding protein concentration for this mean. So the protein concentration from the standard curve. But this time, not just for an individual sample, this time it is for the mean. Yes, I hope the session is recorded. So what is he talking about? A 95% confidence interval. 95% confidence interval. We are undoubtedly using a sample here. So using a sample, this means we only have a sample. We don't know what the true population mean is. So I write it as true population mean. We don't know that, but we want to estimate it, and we have a sample. So in your first year, what you did was you just simply calculated in your first year, you calculated the mean of these, and then you took the individual measurements. I remember now. You took the individual measurements, you calculated the mean of that, and you calculated the standard deviation of these different protein concentrations. That is what you did in your first year. It's sort of semi-correct because it makes an assumption that this standard curve is actually totally 100% on one line. Let me draw it like that. So if all your data are 100% on this line, on this line of best fit, which is also a trend line. And I know that somebody asked yesterday whether a trend line is also a line of best fit. And although there are some slight differences between trend line and line of best fit, I think most people would use it in the same connection. So here our line of best fit has absolutely no differences between the line of best fit and the data points. So that would be the ideal scenario. And that would mean there is no deviation or no uncertainty in the standard curve. And if that is the case, we can easily just simply take our mean of the absorbances, go over and get something like that here. Or we can use the different ones like that and do the mean here and get a standard deviation. And just before somebody asks, this is a sample standard deviation, because it is a sample. It's not a population. And you remember, sample standard deviation, what do you divide by when you have a sample standard deviation? Thank you very much. Yes, n minus 1. So you would always go for n minus 1. And that is what you did in BI308 last year. However, because I'm a mean bastard, as my wife and my children and my dogs will confirm, your standard curve will not be ideal. Your standard curve will be fairly realistic. The cats are demented anyway, so they don't count. So we have microgram BSA, we have absorbance, and we get a standard curve that looks like that. Something like that. This means our standard curve also has uncertainties in it. With uncertainties. So if we take 3 measurements, it's really, we can still pull them together into one, but we have 2 uncertainties in it. 2 uncertainties in what we get down here. One uncertainty comes from our absorbances. This comes from the absorbances. The other uncertainty for that comes from the uncertainty of the standard curve. So these 2 absorbances contribute to sort of an error margin. So a margin of error. We cannot actually say absolutely 100%, the true mean for our sample was 35 micrograms, we have to say there is a margin of error in it. Does that make sense? So this margin of error is dictated by the uncertainty in the absorbances and the uncertainty of the standard curve. Both contribute equally to this error. So we need to find a way how we can actually determine this margin of error. And let me put it this way. This is actually quite mathematically involved. So what I have done is I have, again, produced a little tutorial how you can determine this 95% confidence interval, how you can estimate that. I've done a YouTube tutorial for it. And there is also, I've written a program that allows you to calculate this 95% confidence interval if your standard curve is not perfect. So what I want you to do is I want you to read around this or on this data analysis, on this tutorial, and I want you to use this program in order to calculate your 95% confidence interval for the induced and non-induced samples that you have measured in the spectrophotometer. And if you really want to know how to do it yourself in Excel, there's also a YouTube video by a guy who is absolutely brilliant, who shows you the steps, how you do that. But actually, you don't have to do it because, as I said, I've written here a program that allows you to do this calculation. So what I want you to do is really go through that and determine this 95% confidence interval for the samples with the cell extract. And this then will actually, where am I? This actually will do the, once you've done that, so determine the protein concentration of your extracts, generate the elution profile of the samples, and determine the 95% confidence interval. This will go into your write-up, and I think Rosalind Masterturn has already spoken to you about what this write-up should look like. I don't know anything about the write-up, so please don't ask me about deadline and what should go in. I think these 3 points that I just mentioned, the protein concentration, elution profile, and the 95% confidence interval, these are the key things that should go into the write-up, but I don't know when to submit it. You will also find that when you do the measurements, I think especially for the samples, there is a little counter in there which makes sure that you do all the measurements, that you have measured them all, because when you have measured them all, what you will find is that down here under the run button, that there is a field then where you can record basically your attendance. I don't know if it is a presentation, so I have no idea what the format will be. But coming back to that, there will be then an attendance recording, which you just simply fill in, sort of with your name and your Kent ID, and you then can check under submissions that your that this has been recorded correctly. And somebody has already done all the measurements, so that's great. So you've got the data and you can steam ahead with all the analysis. Does that make sense to you guys? Are you happy with the task? Or do you have any burning questions? As I said, if there are questions, let me know. But please go through this website in the first place. The deadline, well, the suggestion was, well, Peter, you tell them in week 13 and they do it in week 14 so that they've got all the data by the end of week 14. I mean, you can do it now. And I would suggest do it as soon as you can, because then it's out of the way. And you've got all the data, and I think all the stuff together. I don't know when the presentations are or when the deadline for the write-up is, but I always err on the side of caution and make sure that I'm I'm ahead of the game. If you don't have any questions, thank you very much for watching and good luck. And as I said, if you've got any problems, let me know if the program doesn't work or if you get really weird results, which you shouldn't, or if you are in doubt about something, let me know and I'll try to sort you out. Okay? Thank you very much. Enjoy your day and stay sane and safe. Take care. Bye-bye.